Hello students, welcome to Power Tutorials. So today we're going to cover in-text questions of Science Class 10 CBSE board, that is Chemical Reactions and Equations chapter. Okay, so in the previous we already covered three parts of this chapter where I have covered in part 1 I have explained what is chemical reaction, chemical equation, physical and chemical reaction differences, characteristics of a chemical reaction, and also I covered few experiments kind of definitions where we covered zinc granules with dilute sulfuric acid and magnesium ribbon with oxygen, what will happen, those we covered. And then chemical equation, symbol equation, that is word equation, as well as symbol equation we have covered. We have covered balancing chemical equations. And in part 2 we have covered writing symbols of physical states like aqueous, solid, liquid and gas, and the types of chemical reactions we have explained all five, that is combination, decomposition, displacement, double displacement, oxidation reduction. What is exothermic, endothermic also we have covered, and also covered few exothermic reactions which are not combination, so those we have covered. In part 2 these are covered, and part 3 we have covered about displacement, decompositions and oxidation and reduction, and also the few daily examples, that is rancidity as well as corrosions. Okay, those parts we already covered, so I will keep all these part 1 2 3 links in the description of this video. You can check it later for reference, but today as I mentioned we're going to cover the in-text questions. Okay, so all the in-text questions which are mentioned in the textbook for this chapter we're going to cover one by one. Let's see the first question. Why should a magnesium ribbon be cleaned before burning in air? Okay, so let's answer this. Why the magnesium ribbon be cleaned? Because this, suppose this is magnesium, and here in the air what we have oxygen. So when these two combine, it will form as a magnesium oxide layer above it, and it will not allow further oxidation of the remaining metal. So this is nothing but magnesium oxide. So that's why we need to remove, or we need to clean, to clean magnesium ribbon so that magnesium oxide layer will be removed. That is the reason we clean magnesium ribbon before performing any experiments. Then after cleaning we will get the magnesium. This magnesium we can perform for experiments. Okay, let's see the second question. Write the balanced chemical equation for the following chemical reactions. Hydrogen plus chlorine gives rise to hydrogen chloride. Okay, let's solve this. Hydrogen plus chlorine gives rise to hydrogen chloride. Okay, so the equation H2, state also alright, it is gas, chlorine, this is also gas, these two combined you'll get HCl. Let's balance it, you'll get 2 HCl. This is aqueous. Okay, because it is dissolved in fluid. So second one, barium chloride, aluminum sulfate. So I'm directly writing the symbols. Barium chloride is BaCl2, aluminum sulfate, it is Al2SO4 thrice, gives rise to barium sulfate, aluminum chloride. Barium sulfate, aluminum chloride. Okay, so this is Al2, chlorine 2, chlorine 3 here. So let's balance this by keeping 3 barium. So 3 barium, 3 sulfate, aluminum 2, chlorine 6, chlorine here it is, chlorine here it is 6, but here it is only 3, so we have to keep 2 again. Barium is okay, sulfate it is again getting clashed. Let's balance sulfate first. 3 okay, 3 barium is fine. Chlorine is getting changed. Chlorine here it is 6, but aluminum changed to Right. Okay, it is just AlCl3, not Al2Cl. Aluminum is 3, chlorine is 1, so if it get exchanged it becomes AlCl3. Let's check. 2Al, just remove all the coefficients again, let's balance it. Sulfate, here it is 3, here it is only 1, so I'll keep 3. Now it becomes 3 barium. I'll keep 3 here. It becomes 3 barium, 6 chlorine, 2 Al. If I keep 2, 2 Al, 6 chlorine. Yes, now it is balanced chemical equation. Let's see. BaCl2 is liquid, sorry, aqueous, because it is dissolved in liquid. This is also aqueous. BaSO4 is a precipitate, so it is solid, and A2Cl3 is again aqueous. So third one, sodium plus water, sodium hydroxide, hydrogen. Sodium plus water, sodium is Na, this is solid, water is H2O, which is liquid, gives rise to NaOH plus hydrogen, which is gas. Anyway, sodium hydroxide, it is also aqueous. Okay, let's see the third question. Let the balance calculation along with states. Okay, let's solve the first one here itself. Solutions of barium chloride, so BaCl2 plus sodium sulfate, which is Na2SO4, gives rise to insoluble BaCl barium sulfate. So insoluble means clearly it is a precipitate. Sodium chloride, so which is NaCl, is also aqueous. So this is aqueous. BaCl2 is aqueous. Sodium sulfate is also aqueous. Let's balance this. Yes, everything is balanced. Let's see the second one. Sodium hydroxide reacts with hydrochloric acid. Sodium hydroxide is NaOH. Hydrochloric acid is HCl, and both they have mentioned clearly it is dissolved in liquid form. Sodium chloride and water. Sodium chloride and water is liquid. What is difference between aqueous and liquid? I told you in the previous parts. Liquid means pure water. Aqueous means something dissolved in water. Okay. So I need one fine H2O. Okay, everything is balanced. Second. Okay, this both are done. Let's move to the next question. The reaction solution of substance X is used in whitewashing. So what is the substance? The substance is CaO, which is calcium oxide, also called as quicklime. Next, write the reaction of substance X involved in one, that is calcium oxide, above with water. So if calcium oxide is reacted with water, it forms CaOH twice. That's it, nothing. So what is CaOH twice? CaOH twice is slaked lime. This is nothing but slaked lime. So in the previous parts I have mentioned, like if this is applied on walls, what will happen means the carbon dioxide which is present in air will react with this wall, and that will form as a white layer on the wall, which you call it as whitewashing. Okay, so white color which is visible on the wall is not calcium hydroxide, it is calcium carbonate. Why? Because this calcium hydroxide will react with carbon dioxide which is present in there to form CaCO3. It will be solid, but CaOH twice is a liquid, so that's why while applying paint it will be in liquid state, but after some time it becomes solid. Okay, let's see the second one. Why is the amount of gas collected in one of the test tubes in the activity is 1.7 is double the amount of collected in the other? The 1.7 reaction which we are talking about is regarding the electrolysis. I'll just show the diagram which we already explained previously. Okay, so this is the diagram which they are talking about. This is activity 1.7 in textbook. So the activity is something like if you have a beaker, you have two holes, you kept two electrodes, which is nothing but graphites. Okay, I'll write here. The electrodes are graphites. Now just fill with beaker with water, then use 2 test tubes to close it and pass 6 volts battery electricity to this test tubes. What will happen is, after some time you can see some bubbles will be forming from these test tubes and some type of gas will be stored in these 2 test tubes. Okay, so this the point where anode, that is from positive side, it is oxygen, and that negative side, cathode, it will be a hydrogen. Why? Because negative charges will attract each other. Oxygen is negative charge, hence it will attract to positive electrode, and hydrogen is positive charge, so it will attract to the negative electrode. Okay, you can see here hydrogen gas is having more gap when compared to oxygen. So why is that is the question. The amount of gas collected in the one of the test tubes is activity is double the amount of collected at the other. Name this gas. The gas which is double of the other. Gas which is double of other is hydrogen gas. Why? Because water contains 2 hydrogen and 1 oxygen by volume. Hence hydrogen gas is twice of oxygen gas. Why? Because the water molecule formula is H2O. So 2 hydrogens, 1 oxygen. Okay, let's see the next one. So these are the last 3 questions, I guess. Yeah, these are the last 3 questions. Let's solve one by one. Why does the color of copper sulfate solution change when iron nails are dipped into it? So this is the same experiment you already covered. Excuse me. The experiment is, we have taken 2 nails, iron nails, and we have dipped it in a solution which is containing copper sulfate. Copper sulfate is blue in color. Okay, and we have kept iron nails. What will happen after some time? Now previously this is blue color. Now after some time what it will become is the same part the beaker will turn to pale green and the nails will change to brown color. So why this is happening? Because iron is more reactive than copper. So this is a displacement reaction where iron will displace copper which is present in the solution, and the solution will now change to ferrous sulfate, and the copper which is will be collected on the nails. So this way the nails will change to brown color. Okay, I will use the colors so that it will be easier to remember. Now this is already blue, so just write it. It is blue color, but later what I told you, it will change to pale green color. So something like this. Okay, so from blue it is changing to plain green. So if you are remembering, if you are seeing this video, then you will easily remember that which color it is changing to which color. From blue it is changing to plain green, pale green. Okay, so this is a reaction. You can also write it as iron copper sulfate change to iron sulfate or ferrous sulfate and copper. And if I ask you what is this reaction is displacement reaction, where higher reactive metal will displace a lower reactive metal from its solution. Let's see the second one. Give an example of double displacement reaction other than the one given in the activity 1.0. So the activity is barium sulfate plus barium chloride plus sodium sulfate gives rise to barium sulfate and sodium chloride, that is mentioned in that reaction. You will write the second example of double displacement reaction which is sodium carbonate plus calcium chloride gives rise to sodium chloride plus calcium carbonate. So this is another example for double displacement, where you can see sodium and calcium are getting interchanged their positions. And that's balances, it is 2 NaCl, calcium chloride. Yes, that's it. So sodium carbonate plus calcium chloride gives rise to sodium chloride and calcium carbonate. Okay, let's see the last question. Identify the substances that are oxidized and the substances that are reduced in the following reaction. Okay, here itself I will write it. Na is forming to Na2O. So in this reaction, oxidized is sodium, because sodium is getting converted to sodium oxide, whereas oxygen, okay, we cannot say oxygen getting reduced because it is just adding of metal is happening here. So here it is only one is getting oxidized, which is sodium. Okay, what about in second place? This reaction, oxidized and reduction are produced. So in this reaction, hydrogen is getting oxidized. We can see hydrogen is gaining an oxygen to form H2O. What is getting reduced? CO is getting reduced because oxygen from that copper is getting removed. So it is reduced to form copper. So in this reaction we have both. One is getting oxidized, other is getting reduced. Whereas in this reaction only sodium is getting oxidized. Okay. So in this way, all the in-text questions of the first chapter, which is chemical reactions and equations, are been solved. So in the next video, I will try to solve at least few questions of the exercise questions. Okay, exercise questions will be solved in the next video. So as mentioned in previous videos as well, so if anyone wants one-to-one, like one-on-one in the virtual sessions, like I can say like virtual tuitions, if anyone is interested and if you want any virtual tuitions, you can just drop your details to this mail ID, which is powerclasses.snb@gmail.com. Okay, you can drop your details, that is phone number, your name, that's it. And if you are interested for the one-on-one online sessions, that is for 1 hour daily. If you're interested, you can drop these details to my mail ID. I'll check my mail ID and I will contact you and we can discuss. If it is okay, we'll continue, or else it's up to you. Okay. So in the next video, as I told, I will keep you the posted of the recording video regarding the exercise questions of this chapter. Mostly by within 2 days, I'll try to complete this video. Okay. So thanks for watching, and please subscribe and enable notification for further videos.